Hello. Today we are going to be going through this rule in theorems that angles in the same segment are equal. Angles in the same segment are equal. Let's get into the rules and the conditions of this theorem. Let's say I start up with my circle as I have right now, and I am going to mark this point here as point A on the circumference. I'll take another point right here, and I'm going to call it point B. Now, what I have is an arc. I'm just going to highlight our arc. Okay, that's an arc right there. This is arc AB. Now, if our arc then forms angles to the circumference like this, and forms again another one to some point on the circumference like so, okay, forms another one maybe to a different point again like this. We say these are angles in the same segment and they are equal. So if I label this angle as X, then this would be X also, and this would be X also. Two or more angles in the same segment are equal. But let's take a close look at how this theorem works. I started up with an arc, our arc AB, and that arc forms angles which go to the circumference. So I start up with the first scenario, or the first X angle here. I want you to follow. I'll just highlight. This is the first angle. Now the origin or the base of this angle, X to the circumference, is arc AB. And this is also true for the next angle X. I want you to follow again as I form my angle. I started from point A, started from point B, and I formed my angle to the circumference. So they are both originating from the arc AB. Let's take a look at the third one. Okay, I follow and I formed my angle. Again, I want you to observe I started from point A and then point B, then I formed my angle to the circumference. So these three are equal because they are formed by the same arc. So to be more precise, we can add on a condition to this theorem and say these angles must be formed from the same arc. They must originate from the same arc. We also use the word subtended. They must be subtended by the same arc to the circumference. This is so important. To the circumference. If any one of these angles doesn't go to the circumference, then this theorem does not hold. We cannot apply the theorem. They must necessarily stop at the circumference as well as be subtended by the same arc or be formed from the same arc. Now, just to quickly illustrate an application, a quick application of this theorem in a question. We are given here ABCD is a cyclic quadrilateral, okay? AD is parallel to BC. We can see that they are parallel right here. The diagonals DB and AC intersect at point X. So remember, diagonals are straight lines which connect vertices in a shape from one corner to the other. That's a diagonal. From one corner to the other. That's a diagonal. So lines that connect corners of a shape or vertices of a shape are diagonals. So our two diagonals meet at point X. Check, this is information. Then we are told that angle ACB is 62. We can see that. Angle ACD is 20. We can see that as well. So you want to make sure before you start answering a question, you read the information very well, because some of the information or tips or clues that you're going to use to answer the question are provided to you in the information. Okay, so I'm only taking part A of this question. The question says find angle DBA. I'm going to highlight this angle in focus, angle DBA, meaning our focus is on angle B. We are looking for the size of this angle here, DBA. So the angle in the middle is always your focus. When we are given three letters this way, this is how we name angles. So DBA, but the focus is angle B. So you start from point D to B, back to A, and the one in the middle is our focus. Looking very closely, I have an arc. I'll highlight the arc DA. I have this arc here, and I want you to follow. If I start from point D and go to point C, then I start from point A and go to point C as well, I can see an angle of 20 degrees formed from the arc DA or AD. I'm going to do this one more time, but this time I'm following D to B and A to B. I can see another angle formed to the circumference by the same arc, originating from the same arc. And from our theorem, we said angles in the same segment are equal if they are formed from the same arc and all go to stop or touch the circumference. So if our angle C there is 20, it automatically follows that our angle B is 20 degrees. So the solution to part A of this question is 20 degrees. And right here, I used the theorem, angles in the same segment are equal.